Okay, good morning everybody. Chris Young here. Welcome back to N5 Maths. And today we're going to continue talking about surds, S-U-R-D-S. And I didn't mention in the last video, but I actually researched where the word surd comes from. And apparently it means deaf to reason. And it's linked to the word absurd. So I thought that was quite interesting. So we're going to study more mathematical concepts which refuse to be rational. But a quick review of what we did last time. Can we remember what we did last time? Yes, Chris, I hear you reply. Okay, then tell me what we did last time. We did something to do with numbers, I believe. And the mnemonic was, do you remember the mnemonic? Nap with zoologists quite rarely, I believe, was the mnemonic. And this was grouping numbers into sets. Nap is your natural numbers, 1, 2, 3, 4, 5. W with, W is whole numbers, so that's including 0, 0, 1, 2, 3, 4, 5. Now with zoologists, Z, that's integers, so that's negative numbers as well. So -1, -2, -3, 0, 1, 2, 3. And that was a quite Q, it was your rational numbers, Q. Okay, so rational numbers, so these are numbers which behave rationally in times of stress. For example, fractions, negative numbers, decimals, basically every number which doesn't make you slightly crazy is a rational number. And then R, for some reason, stands for irrational numbers, and that's your pi's, your imaginary numbers, I presume, and also your surds. And of course, I'm sure you remember, there's no need to go into this, Chris, we remember what surds are. A surd is like a root of a number which cannot be made into a rational number. So for example, the square root of 2, if you put that into a calculator, it's like 1.4 dot dot dot. But the trouble is, at some point you're going to have to round it up or down or stop. And then when you do more calculations with that decimal number, there might be, further down the line, there might be a bigger discrepancy. You might be further away from the real root 2, the exact value of root 2 than you started with. So why not just keep it as root 2 for as long as possible to avoid headaches further down the line? Now it turns out that this is very important in manufacturing, because let's say you're a manufacturer and you want to, well, the example in National 5 Maths by Lecky, formerly known as Lecky and Lecky, the educational publishing for Scotland, it says, imagine you have to make discs out of a strip of metal, which is 100 centimeters long, right? So you've got a strip of metal which is 100 centimeters long, and you have to make discs. How many discs can you make out of a strip this long? And imagine the diameter of each disc is √5 centimeters. Okay, so what is √5 in centimeters? Hey Siri, what is √5 in centimeters? Siri's not listening at the moment because I'm using it as a video machine. But according to my trusty Texas Instrument from the 80s, which still works kind of, the root of 5 is 2.236067978, and that's when it stops. So don't worry, you don't have to remember this for the exam. I hope. 2.236 centimeters. Okay, so that's what we're talking about. How many of these discs diameter 2.236 centimeters fits into 100? Well, let's just round it down to 2. Let's just keep it simple, because you know I'm a contractor. I need to do things quickly. 2 centimeters. Let's say it's about 2 centimeters. How many 2 centimeters going to 100? Well, that's 50, isn't it? So okay, that's good. Right, job done. Right. Okay, coffee break time. No, wait. That seems a bit rough to me, guys. Come on, hey, let's think about this for a second. 2.236, that's almost another quarter more. So, like, let's say 2.2 centimeters. That's a bit better, isn't it? 2.2 centimeters. Now, how many 2.2s can we get into 100? 100 divided by 2.2. It's okay, Siri, I got this. You, 45. 45 and a bit. Okay. Whew, I'm glad we made that calculation a bit simpler. If we'd been confident of getting 50 discs out of a strip, 100 centimeters, and only got 45 discs, well, that's 5 discs. Imagine it's £1 per disc. That's 10%. It's a 10% difference. Imagine losing 10% of your profit. Come on now. Now imagine, let's say if we calculate root 5, I mean, you're going to have to simplify it at some point anyway, aren't you? Root 5, if we just say root 5, then it's 100 divided by root 5, isn't it? But you're going to have to tell somebody what the number is. Let's make it as exact as possible. Well, anyway, it's 100 divided by root 5, isn't it? So let's say we go 100 divided by root 5. I'll just plug that straight into the calculator. Look, 100 divided by root 5. Can you see that? 100 divided by root 5, 44.721. 44.721 discs. So we can't get 0.7 of a disc. So we're going to have to, we know that it's only going to be 44 discs is the maximum number. So you can see how this is useful in the manufacturing industry and probably other industries besides. I didn't realize Surds were so rational. Okay. Now, let's take this to a whole nother level, right? Imagine, this is a little thought experiment here. Imagine you are an eccentric billionaire, okay? What are you going to do with all that time and money? But build an escalator to the moon. Okay? That's what you're going to do. You're going to build an escalator to the moon because nobody's done it before and it's kind of crazy. Okay, the question is, how far is it to the moon? 384,400 kilometers to the moon. Now imagine you have to make the escalator out of triangles because triangles are the strongest shape known to man, apparently. And you have to do it with triangles measuring 3 meters by 3 meters of an edge. How many of these triangles is it going to take to get to the moon? Well, let's have a look. According to old Mr. Pythagoras, a close personal friend of mine, we need to figure this out. I believe Mr. Pythagoras said x squared is equal to 3 squared plus 3 squared, right? Which is, if I'm not mistaken, 9 plus 9, which is 18, right? So x is the square root of 18 meters. Okay? Which can be simplified, I believe, because it's 2 times 9, and 9, square root of 9 is 3, so it's actually 3 root 2 meters. Okay, don't worry Siri, I got this. 3 root 2. So I don't even have to type in the times. My calculator knows what 3 root 2 means. I just put it in. And the answer is 4.242. So x let's see, I need some space. Sorry, diagram. That was a nice picture, but let's say it's 4.2. 4.242. 4.242 dot dot dot. All right, 4.2. Let's say it's just 4 point. Let's just say it's 4 meters. That's close enough. So if it's 4 meters, how many triangles does it take to get to the moon to build this escalator? Well, you need to divide this number by 4. Okay, 384, comma 400, and then another 000 divided by 4 is, oh man, 961. 961 000 000 961 000. Okay. 96,100,000. No, what was that? Yeah, 96,100,000 triangles it would take to get to the moon. All right. But if you've watched this video, you would say to your eccentric billionaire, well, wait a minute. Maybe we should calculate it a bit more closer. Let's try 4.2 meters. So 384, 400, 000 divided by 4.2, because that seems slightly more accurate. 91523. Whoa. That's a big change. 91523. 809. 0.5. So that's, see what I'm talking about here. That's 5 million steps different just by making it slightly more accurate. But then you're going to say, well, wait a minute, we haven't done the surd thing really. Maybe we should do that before we make a final answer. So what's that divided by the surd? 3 root 2. 3 root 2. Okay. 384. 400. 000. Divided by 3 root 2. I don't even need to put any other symbols in. What's the answer? 9060. 9060. 3948. 3948. 0.9. What's that? So this is with using surds to get the actual number of triangles you're going to need to build your escalator to the moon using surds. Much more accurate answer is 90,603,948. We'll round it up. We'll put some rocks down on the moon. It should be fine. 949, we'll just say. And how much different is that from your original answer? Let's subtract the original answer from that number, 961 000 000. It's 550. Oh, it's 5 million. 5 million. 5.5 million different. So that's a lot of steps. So if you'd used this first answer, you would have ended up with 5.5 million more steps than necessary. So somebody would have got the chop, but then again, your boss is an eccentric billionaire. He probably would have let you off with a warning. So ultimately, this is all pointless. Anyway, that's all from me. I hope you found this lesson interesting. I found it interesting. I before I started this video, I thought, oh God, not surds again. How am I going to make this interesting? But actually, I think it's been quite interesting, even though I do say so myself. Thank you very much for watching. If you have any questions, please don't ask me, because I'm This is all new to me as well. Well, you could ask me, put them in the comments if you do have any questions. But that's me approaching 15 minutes. We better finish now. Cut, cut, cut. See you next time. Goodbye.